Standing on the shoulders of giants. This is the story of PostNL, how we embraced serverless, how the benefits it brought us, the challenges we faced, and how we overcame them. But before we start, I must warn you, this is not a technical talk. This is about big enterprises, about modern software. It's about trade-offs, people, and culture. If you're looking for more technical deep dives, luckily we have enough content today for that as well. So make sure you attend the sessions by Luke, Luciano, Matthew, many others. My name is Luc van Donkersgoed. I'm an AWS serverless hero and principal engineer at PostNL. And PostNL is the Dutch National Postal Service. On average, we deliver 1.1 million parcels per day. We have 37 sorting centers, and we employ over 33,000 people. In other words, we have a very large logistics network, which is powered by advanced logistic algorithms and processes. And the application landscape powering these processes consists of over 70 applications, which are built and maintained by over 30 in-house development teams. And we have been building our logistics network for a long time. PostNL is a very old company. We can trace our history back under various names to 1799. So this year, we're celebrating 225 years of logistic history. Now, of course, you don't get to the ripe age of 225 without adapting to constant change. So over the centuries, we adapted from horses to cars, from physical post offices to the internet, and from letters to parcels. In the past few decades, software has really become an inextricable part of PostNL's operations. But the way we approach software has significantly changed since 2012. Before 2012, we mostly used commercial off-the-shelf and vendor-built solutions, which were hosted in our own private data centers. In 2012, we decided that maintaining our own data centers should not have our primary focus, and we migrated everything to AWS, making us one of the first European enterprises with a public cloud-only strategy. In 2018, we realized that to remain competitive in a fast-moving market, we had to build our own logistics software. So we explored our options and we found that cloud-native and serverless solutions on AWS were the best fit for our business. And we focused our engineering departments on embracing this technology. So why choose serverless as the foundation of our new engineering strategy? There are a few reasons. And the first is elastic pricing, or pay-per-use. And this is very relevant to our business because in an average week, a workload on one of PostNL's applications might look like this. And as you can see, we hardly process any volume during the nights and the weekends, but we experience peak loads on Tuesdays, and especially around noon. Because this is when all of our delivery drivers are out, but also when our customers and consumers are using our apps and websites. But because our entire landscape is serverless, we hardly generate any cost during these off-peak hours. And with patterns like these, this can lead to big cost reductions when compared to always-on systems. The next reason we choose serverless is because of effortless scaling. Now, of course, effortless scaling is very important when you have patterns like this, but this is not the only seasonality that we see at PostNL. Here we see another usage pattern. This time it's covering about 6 months. And you can still see the weekly seasonality because every one of these bumps represents a single week. But you also see another pattern, which is increasing load towards the end of the year. Now, can you take a guess at what causes this pattern? Anyone will be here all day if you don't answer, so. Christmas, exactly, the holiday. Because it's the holiday season, and in November and January and December, we process significantly more volume, about twice as much as we do in the summer months. And even in the weeks after the holiday season, we process more return volume. But by embracing serverless, we don't even have to think about the increased load on our applications, because the applications automatically adjust to the load. Of course, our AWS bill will be higher, but as we're moving more parcels, our revenue also increases, so the higher cost is automatically covered by the higher revenue. So we've covered elastic pricing and effortless scaling. And these are great attributes to have in the serverless landscape. But to me, they aren't even the most important reasons to choose serverless. So let me ask you another question. Can you tell me what the two most expensive components in software engineering are? I'm sorry? Human labor, that's one. And the other one is outages. So let's talk about these topics. The most common cause of outages are infrastructure problems. So among other things, I'm talking about hard drives filling up, or physical hardware failing, or network congestion, or misconfigured networks. There are so many moving parts to infrastructure that building and maintaining it is an extremely valuable specialism. And as an enterprise, you must do it right, because outages are super expensive too. If our logistics network is down, our sorting centers can't work. Our delivery drivers can't drive out. And maybe our customers might demand compensation. And this also means that if you make application builders responsible for their core architecture, their core infrastructure, it will take them significant time and effort, which they will not be spending on creating customer value. Now, alternatively, you could create distinct platform or operations teams, but these are super expensive as well, and generally not a core capability for many enterprises. So instead, PostNL chose to mandate the use of serverless, which allows us to delegate the most difficult infrastructure problems to AWS. For example, we don't think about physical CPUs, their capabilities, their instruction sets, their compatibilities. We just use Lambda, or step functions, or Fargate, and AWS manages the physical capacity. Likewise, of course, we're using a network to communicate between our applications and services, but we don't think about bandwidth, or throughput, or speed, or volume. AWS just manages anything we can throw at it. And then there's high availability. And this is an extremely important but also very complex topic. It involves availability zones, failure detection, failover, immutable resources, and many other complex topics. But with serverless, we get all of this out of the box. We just write an object to S3 or a message to SQS, and Amazon takes care of the rest. And another great benefit of using managed services is the security responsibility carried by Amazon. For example, when the Log4j vulnerability was found, Amazon patched their applications, their operating systems, their runtimes. They even patched the Lambda service to protect customer application code from abuse. And likewise, they patched their infrastructure and their operating systems for the Heartbleed vulnerability with no customer impact. And I think this diagram is such a great way to tell that story. All the way on the left, we have on-premises. And now, as an enterprise, you're responsible for the entire stack, the data centers, the network, the power supplies, the security, the operating systems, everything. Well, all the way on the right, you have serverless. And now Amazon is responsible for almost the entire stack. They run the data centers. They do the physical security. They do the high availability, the operating systems, the runtimes, the patches, almost everything. And if you use a fully serverless application like S3 or DynamoDB or SQS, they manage even the application itself. You just use an API and you configure the service the way you need it. So, what are the results? After 5 years of serverless, we have significantly reduced the number of incidents and outages at PostNL. We have also created dozens of teams which have released thousands of features over the years. We've also brought down overhead, both in a financial as well as in a productivity sense. And because we moved all of our development teams in-house, our teams are now much better aligned with organizational and strategic goals. So we embrace cloud-native services, and we never look back. It's all roses and unicorns in serverless land. Or is it? Of course not, because nothing good comes without a cost. So let's talk about trade-offs. As any software architect will tell you, everything is a trade-off, and so embracing serverless is no different. So let's take a look at 4 commonly heard arguments against serverless and cover their trade-offs in turn. First, serverless locks you in. And this is probably the most commonly heard argument against serverless, and honestly, I'm not even going to argue. It's true. If you embrace serverless, leaving AWS is going to hurt. But what's the alternative? You can try to avoid AWS services as much as possible and maybe invest in other platforms like Kubernetes. But have you seen the operational complexity required to run production enterprise workloads on that platform? If you go that route, you take on the responsibility of building and maintaining that entire platform yourself. Well, with serverless, you're locked in, but as a trade-off, you get to delegate the entire platform maintenance to AWS. The second argument is that serverless is expensive. Jeremy talked about serverless cost this morning as well. And people say that running enterprise production workloads on serverless will break the bank. And in this case, I might agree that the cost per event, or the cost per request, or the cost per gigabyte is higher than in non-serverless systems. But again, this is a trade-off. Because for this price, you get all the benefits we discussed before: scalability, maintenance, security, and hundreds of new features released every year at no additional cost. And remember the price of outages as well. By using a highly stable and available platform like serverless, you're reducing the amount of incidents. And if you include these costs in your total cost of ownership analysis, you might find that the higher price per request or per event might be well worth it. Third, serverless is too complex. People say that a simple application requires at least 4 services, and you need to know exactly how they work together, how they fail, how they scale, what their limits are. But I would argue that this complexity is actually a good thing. Because in fact, an application running on EC2, or in your private data center, or in Kubernetes will likely have exactly the same components, but they're invisible, they're hidden in your platform or hidden in the internal workings of your applications. Which means, again, that you're responsible for maintaining it. Serverless brings this complexity to the surface, where it can be documented, analyzed, debated, replaced, all while Amazon remains responsible for its operations. And then finally, serverless is too opinionated. And again, I'm not debating that serverless is opinionated. It is, and very highly so. but most of the time this is with good reason. The limits and restrictions imposed might protect an internal architecture, or they might force you to use the application, the service, the way it was intended. Or it might protect customer data in a multi-tenant system. The way we see it is that it's better to work within the limits imposed by an opinionated system than try to break out of them. So let's explore this topic of opinionated services a little deeper. It's no secret that Amazon builds services that scale. For example, Amazon S3 processes 100 million requests per second. DynamoDB peaked at 126 million requests per second during Prime Day 2023. And Lambda processes more than 10 trillion invocations per month. So running infrastructure at those scales require very strict architectural principles and operational excellence. So AWS has decades of experience building, running, and maintaining the largest services in the world. They have experienced firsthand what works and what hurts. And the services in the serverless ecosystem are the embodiment of that experience. So by using serverless services to their fullest extent, your applications automatically gain a base level of maturity that typically takes years to build. So in the end, PostNL's serverless strategy comes down to this. Our operational services need to be reliable at all times, under any load. Distributed, decoupled, and elastically scaling serverless architectures help us achieve this goal. They greatly reduce the operational burden and the number of incidents. In other words, they reduce runtime pain. But we can only get these runtime benefits by investing time and effort at build time. So embracing serverless does have an impact. If we're going to use serverless to its fullest extent, we need to know its capabilities inside and out. If serverless is expensive, we need to know how to optimize for cost. If serverless is complex, we need to train our engineers. And if serverless is opinionated, we need to know the rules of the game so that we can use them to our advantage. So what does this mean for the serverless engineer at PostNL? What skills do they need? What challenges do they face? Of course, they need to be very familiar with the serverless ecosystem. They need to know about the available services, their use cases, their limitations, their failure modes, and how multiple services like SQS or SNS or EventBridge compare to each other and when to use which. They also need to be able to design for scale. So they need to think about queues, buffers, backoffs, throttling, and more. And at the same time, they also have to design and build with cost in mind. Of course, they could just store every parcel update in DynamoDB. But would that really be the most efficient solution? Maybe some solution involving S3 or Kinesis Firehose can be used to solve the same problem more efficiently. And finally, our engineers also need to think about the operations of their workloads. Which metrics are important? What do they need to alarm on? And how are they going to make their applications observable? And this last part, designing for operations, actually requires a bit of additional attention because it's a difficult topic. In our case, our engineers run their own workloads, which means they have on-call duty and they respond to incidents. Because after all, even if you use a highly available service like Lambda, which is almost never down, never unavailable, your applications might still process unexpected inputs. And when this happens, hopefully, this results in a controlled failure, such as a message being put on a dead letter queue. And it is then up to the engineers to investigate the root cause of this issue, of this incident, to solve it, maybe to redrive the message, and then look at how they can improve their architecture to prevent it in the future. And another common problem faced by our engineers is hitting service limits, especially at the scale that we operate. So example service limits are the amount of maximum concurrent Lambda invocations or the maximum requests per second handled by API Gateway. And when these occur, our engineers need to contact AWS support, see if they can resolve the limit as quickly as possible, and then the next day they need to look at their architecture and see how they can evolve their application to avoid hitting this limit in the future. And again, the solution might need require something like buffering, throttling, exponential backoff, and so on. So in a summary, our engineers need the knowledge to know what tools and services are available to them. And they need the experience to make the right decisions. This is not easy. It requires long-term investment in people and culture. And one of the ways we do that at PostNL is by investing heavily in formal education, such as classes and workshops. And we also foster our engineering community by hosting knowledge shares and community-led tech improvement charters. We have found that continual learning and experimentation is essential to support a cutting-edge software company. At the same time, we've seen that a very effective way to promote good serverless engineering is by making the right thing easy. For example, we have one-click solutions to deploy new AWS accounts, which are then automatically integrated in our network architecture, in our security services, cost monitoring, and version control. But of course, we also need strict guardrails. So for example, we have service control policies in place which prohibit the creation of EC2 instances and IAM users. And this forces our developers to make the right decisions regarding cost, security, and operational overhead. So what have we learned? Embracing serverless in the enterprise is good for cost and reliability. But embracing serverless is not a flick of a switch. You don't decide to be a serverless enterprise and ta-da, you're it. No, instead, you need to invest in your processes, in your guardrails, and the AWS platform itself. You need to make the right thing easy and the wrong thing hard. And most of all, you need to invest in your people and culture and hire the experts who can build your serverless future. We have seen that the more we invest in serverless, the more we can get to delegate to AWS. They become responsible for almost the entire stack, including its high availability, security, and reliability. And because serverless services are built to the highest standards imaginable and work under the highest workloads imaginable, and they have decades of experience ingrained in their architectures, we have found that by using serverless, we truly get to stand on the shoulders of giants. Thank you.